Let's practice this. So I have this equation this time, and I have these four things. So I'll start you off and then have you go off and finish it. So first thing, I notice that the equation I'm graphing is an exponential, not a logarithmic. So since it's exponential, that means I'm going to want horizontal asymptotes. And because it's exponential, that means my domain is negative infinity to infinity. So now that I've got those in place, because I know this is an exponential, I would like you to pause the video, try to actually find our three things, x-intercept, y-intercept, and horizontal asymptote, using the rules we just talked about in the last video, and then come back to see if you are right. Let's see how you did. X-intercept, set the equation equal to 0, give the exponential by itself, and at this point there are two ways you could do this. You could say 1 is 3 to the 0 and use the 1-to-1 property, or right here you can change the form and get log base 3 of 1 equals this. Log base 3 of 1 is 0, so you end up getting the same equation either way. End up solving that. We have an x-intercept at negative 1/2. Comma 0, and put it right there. Here, let's color code it. Next, we have a y-intercept at 0, 2. And then lastly, I have my horizontal asymptote at y equals negative 1. So I fill all those in, and then it's pretty quick to see. I got my hockey stick shape, and we're good to go. Let's try our last problem, example 7. So once again, we have domain, x-intercepts, y-intercepts, and asymptotes. We look at the equation and see that this is once again an exponential. So our domain is negative infinity to infinity, and it will be a horizontal asymptote because it is an exponential. So same thing, pause the video to find the three things that we need. And then you can come back to check your answers and see how you did. Let's see how you did. X-intercept, set the equation equal to 0. I changed the form to see, hey, I cannot plug a 0 into a logarithm. That doesn't work. It's a domain error. So that makes me think that there are no x-intercepts, which tracks because when I found the horizontal asymptote, because there are no outside rules, this horizontal asymptote is y equals 0. So of course there's not going to be any x-intercepts on the x-axis because it's an asymptote. And the last point I got is my y-intercept there. Now, when I look at this right here, I notice pretty quickly that this is not enough information to really see this graph. You can't really know what a graph looks like by having a single point. So I'm going to do, when all else fails with graphing, something I can always rely on is a t-table. Plug x values in, get y values out, and plot them as a point. Honestly, you can do this for any graph you want. You can always plug points into a t-table and then graph them and connect the dots. So we already know that if x is 0, my y value is 10. So let's go on either side of that and plug in negative 1 and positive 1. So 10 to the 1 minus negative 1 squared equals 10 to the 1 minus 1, which is 10 to the 0, which equals 1. So I'm going to graph the point negative 1, 1. Now, you might be tempted to say, hey, look, there's my hockey stick, and draw it and be done. But be very careful. If I plug positive 1 in, I get 10 to the 1 minus 1, which is 10 to the 0, which is still 1. So 1 comma 1 is another point on my graph. And you'll notice very quickly this is not looking like a hockey stick shape. So let's try positive 2. So I get 10 to the 1 minus 4, which is 10 to the negative third, which is 1 over 10 to the third, which is 1 over 1,000. That's a very, very small fraction. So at 2, I have this point, and if you plug in negative 2, you'll actually get the same thing. So now you should be able to start to see what this graph is looking like, which definitely is not the hockey stick shape. So last thing we want to talk about today is why this graph is not looking like our hockey stick shape. Because the last graph did. This one looked like a hockey stick, so why doesn't this one? If you look at it for a second, you'll notice really quickly what's in the exponent. Here I have an x squared in the exponent. Here I just have a 2x. Well, what does the graph of x squared look like? Well, specifically, negative x squared. Negative x squared is a downward facing parabola, sort of like this. So this graph is a combination of the downward facing parabola and the exponential. That's why it looks so weird. So basically, moral of the story, if your exponent is just plain x's, then it's still going to look like your hockey stick shape. If your exponent has x squared, x cubed, anything weird in it, it's not going to look like your hockey stick shape anymore. So that is all we have for lesson 4.3 today. You are good to start on your homework. Good luck.